Today we are learning 11.3, simplifying rational expressions. Clearly the goal is to simplify expressions, and as a reminder, what do rational expressions look like? Rational, I often like to say, if we just added a C between the A and T and an F, we'd have fractional, right? That's actually what rational means. Generally speaking, rational means we involve fractions, typically with variables in the numerator and or denominator, could be both. To simplify a rational expression, we cancel just like we would with fractions, right? If there's something in the numerator that can cancel with something in the denominator, then they can cancel. They can cancel by either being one of two things. They can either be the exact same, like if we had a 3 in the numerator and a 3 in the denominator, those would cancel y, right? 3 over 3 is 1. So basically, they cancel each other out, right? So those could cancel. Or we could run into something like, let's use variables. Let's say x squared and x cubed, right? These could cancel, but only partially, right? Because this is the same as if we had 2x's, and the denominator is the same if we had 3x's, right? So they can cancel, but we're still going to be left over with something, right? These cancel, and what goes where the canceled area is, right? These cancels are switched to a 1, just like 3 over 3 didn't disappear and become 0. This meant they were equal, so it was equal to 1, right? Now, in this case, we would have ended up with 1 over x. And then lastly, even though I said there was two cases, this one's a little more specific to the next slide, would be what if we have fractions that have like values. For example, let's think about, how about 20 and 12, right? 12 does not go 100% into 20, right? 12 goes into 12, 24, 36, right? We can count by 12s. 20, same thing, doesn't go into 12. However, they both are even, so we could divide by 2. They also both are multiples of 4. So when we simplify, I typically like to say, divide by 4, and then we'll get 20 divided by 4 is 5. 12 divided by 4 is 3, and 5/3 is completely simplified. Okay. Now, here's the example we'll be seeing today. We've got 4x over 20. Now, these first ones are a little more basics. The further ones we get into will have a lot more parentheses pieces. So, what we're looking at is, okay, can we deal with the 4 and the 20 somehow, right? 4 goes into 20 5 times. So we're going to cancel here. This would be a 1. And now, generally speaking, I'll write a 1 if everything cancels. If there are things left over, like in this situation, there's an x. Typically, I won't write the 1 because, well, now it's just x, right? If I read it without the 4, it's x, or 1x, right? Those are the same thing. But now I divided by 4 here. I need to divide by 4 here, which will get me 5. So usually I cross out and I either rewrite a number next to it or below it. And now that's it. Now we have x. Nothing can cancel with x here. So this is 1x over 5, or I'd write it as x over 5. Next one, we've got 2 times quantity x plus 3 all over 6. Okay, well, in order for an x plus 3 to cancel, I would need a perfect match. I would need another x plus 3 in the denominator. Okay, so if something's in the numerator or top, it needs an exact match in the bottom, parentheses-wise, to cancel. So that's not going to cancel, but 2 goes into 6 3 times, so divide by 2, and I'm going to get 3, and so this is going to be x plus 3 over 3. Now, we can't cancel further despite saying, oh, we got a 3. 3, they match, they cancel. No, canceling doesn't work like that, because remember, this has parentheses, right? This is not 3 divided by 3. This is x plus 3 divided by 3. So 3 doesn't go into both pieces. We cannot cancel, and you won't be doing that type of cancel here. I'll give it to you already ready to go, and you just need to cancel or simplify what could. Next, we've got negative 18 x squared over 12x. Okay, now we've got number-wise, negative 18 and 12, both even, so we can cancel here. But how much, right? You want to find the largest number that goes into both. So 2 works. How about 3? 3 goes into 12. 3 goes into 18. Okay, 3 works. Um, but how about both 2 and 3? 2 and 3 multiply to get 6. And so 6 is in 18 and 6 is in 12. So we're going to divide by 6 to get 3. So now I'm going to write 3. It's not 1, so I'm writing the number there. Over here, divide by 6 and I get 2. No, I don't like just canceling the 1, so it looks like 2. So I'm just going to cancel the 12, and now there's a 2. And then on to the next part, x squared x. Again, this is basically how many x's we have. I have 2 x's here, 1 here. So 1 cancels, and normally we'd subtract 1 if you remember our exponent rules. However, because when we take 1 away, we're left with 1, right? So you could either do it that way, or I also like to just cross out the 2, and now it's just 1x right there. So you've got a couple options there. Now, if it is, let's say it was, just for one moment, what if it was x over x cubed? Can we just cancel that way, right? Why we can't cancel that way here is because we can't just say, oh, there's no more 3 here. This is 3 x's and 1. When you subtract 1, there's 2 left over. So that's why if I canceled this one, I would just cross it out and then write 2 for x squared. Okay. So just a little note that because this one gave us 1 left over, that's why I would sometimes just cancel the 2 out. Now finishing it off, sorry to get distracted there, we got negative 3 over 2, and then 1x is left over in the numerator, so negative 3x over 2. Now there's not a lot of work shown. Clearly most of it is shown while we're doing the video here. So just be aware that some of your work is you rewrite the original question down and then you cancel like this. It can get a little messy, so you want to make sure you leave yourself enough space. Next, 24x squared over 8x cubed. And again, some of these, go ahead and try on your own. Pause the video and see if you can do it to see how close you're getting to right, or maybe you're getting it all right. And going through here, 24 and 8 both have an 8 in them. This will have 3 left over. We've got 2 x's here, 3 down here. So 2 on the bottom will cancel. These 2 will go away, and we're going to subtract 2 to get x to the 1. And all I have left on the top is 3 over x to the 1. So 3 over x would be my final answer. Next one, I've got 18 and 27. I see 3, I see 9, right? 9, both of those. So if we divide by 9, I get, almost from 9, we get 2. Divide by 9, I get 3. And then this has 1y, 2y's. Well, one of those 2 cancels, and we're left with 2y over 3. Next, 35y over 14. 35 and 14 both have a 7, so divide by 7, I get 2. Divide by 7, I get 5, and we get 5y over 2. Don't forget that anything we didn't deal with is still there, right? The y didn't cancel, so it's still there. So 5y over 2. Next up, with these, it's simply match parentheses. Now make sure everything in the parentheses match. So if I have an x minus 4 and x plus 4 in different positions, one's on top, one's on bottom, because plus and minus aren't the same, they wouldn't cancel. If I had an x squared plus 1 and an x squared or an x plus 1, again, those don't cancel. So I made it so that they're already broke down for you. We didn't have to factor, but you're looking, I got x plus 3, x minus 4 over 2x plus 1, x plus 3. These are the same, so they cancel, and then whatever's left over gets rewritten. So x minus 4 will be on top, 2x plus 1 on bottom. Now, a good question would be, what happened to your parentheses? Are you forgetting your parentheses? Now, technically, when we write fractions like these, there are invisible parentheses here, and I only am allowing you to not write the parentheses when we only had one piece left. If I had x minus 4 and maybe a 2 or a 3 left over, you would need to rewrite the parentheses, right? But you don't need to write them if we only have one piece left, and these are considered one piece. Next, we've got 4, parentheses x minus 6, parentheses x minus 3 over 2, parentheses x minus 6. Now this is kind of a mismatch here. We have some that are easy cancel, like right here, quick cancel. They're both the same, they cancel. Some that, I got x minus 3, nothing's canceling there. 4 and 2 are the old cancel from the fraction ones, right? 2 goes into 4 2 times. So divide by 2, divide by 2. Because both of these things are gone, it's like they're over 1, right? So now I have 2, and whatever's left over we multiply. I've got 2 and x minus 3. We are not simplifying, but we're just going to write that. Oh, that is 2 times x minus 3 over 1, right? We still have a 1, but any number divided by 1 is itself. So then you can just write this as 2x, 2 times parentheses x minus 3. Next up, we've got the same idea. 2 times 3x minus 5 times 2x plus 3 over 6 times 2x plus 3 times 3x plus 5. Now notice, we have some of these that look very similar but aren't the same. So starting off this time, we'll start with the numbers. 2 goes into 6 3 times. 3x minus 5, 3x plus 5, not the same. So those are going to be left over. 2x plus 3, 2x plus 3. There's our next cancel. And I have 3x minus 5 left over on top. And I've got 3 times 3x plus 5 on bottom. And that is our final answer. Next one, we've got 2 times x minus 6 over 6 times x plus 9 times x minus 6. Again, 2 and 6, just like last time, right? Divide by 2. Divide by 2, I get 3. X plus 9 can't cancel. Moving on. X minus 6 cancels. And we've got nothing in the numerator. So I'm going to write a 1 up here. 1, because when it cancels, right, that's 1 over 1. So you still need to write a 1 when everything cancels. In this case, why didn't I write a 1 here? Well, we still have x plus 9 and 3 left over. So I didn't need to write a 1 times that. Because, 1 times 3 is 3. It wouldn't change, right? It would get kind of taken over by the 3. So we had 1 left over in the numerator, 3 times x plus 9 in the denominator. Now this last one, try on your own, and then I'll walk through it. Once you've paused, now hopefully you've unpaused, and then looking, we've got 5 and 25. 5 goes into 25 5 times. We've got x squared minus 3, x minus 3. Not the same, so that's going to stay. The squared's not going to cancel with this because x squared is different. 5x plus 6, 5x plus 6. So we're going to have x squared minus 3, no parentheses on top because it's the only thing left. 5 times the x minus 3 on the bottom. And that's it. And then the last one here, 14x over 7. Well, 14 and 7 divide by 7, we get 2. Just because the x can't cancel, that's fine. We'll have 2 and x left over, right? But x minus 8 cancels. And so this one will have the whole bottom canceled. So I like to write a 1 to remind myself there's still something there. But anything divided by 1 is itself, right? 2x divided by 1 or 2 divided by 1 is 2 times x. And there we are. And that wraps up today's lesson. Feel free to email or classroom private message me if you have any questions.